level of detail expressions, exercises, table scoped. In this exercise, we will look at what happens when you do not have a scoping keyword. Note, this is extremely useful and I use this regularly in my work. So let's go to Tableau. So we'll start by going to Microsoft Excel and loading in our sample Superstore data source. Take orders, let's drop it in. And now we are going to create our table scoped level of detail expression. Let's create a new calculated field. In the formula, I just want to put the following: min, order date, close the bracket, close the level of detail expression. That's it. As simple as that, we have now created a level of detail expression that calculates the minimum order date for the entire data source. How do I use this? Typically I don't use min, typically I'll use max to get the most recent date within our data set. So this is a very quick way to just getting the total number and putting it into a dimension. So now that we have this. So for example, I could use this in formulas now if my order date is equal to min date, or if my order date is equal to max date. There's a lot of ways we can play with this, but this is how you create a table scoped level of detail expression. Exclude the scoping keyword, no dimensionality, just the curly brackets around your aggregation. Enjoy. Level of detail expressions, exercise, customer order frequency. In this exercise, we will write a fixed level of detail expression to help us visualize customer order frequency. The key here is that we want to know how many orders each customer has made, and then we want to bucket them. Therefore, our LOD expression for each customer at a customer level, we will count the number of orders. So let's go into Tableau and do this together and build a fun visualization. With Tableau desktop open, the first thing I want us to do is go to Microsoft Excel. Let's load our sample Superstore data source. Let's bring that into Tableau. Let's take orders and drop that in as well. With our data loaded, we are now going to click on sheet 1. So the key thing here is that we will start off by creating our expression. Let's go to create calculated field, and what we're going to do is call this number of customer orders. We'll start off with our open curly brace. We are going to use fixed because we want to ensure that this calculation is done for the dimensionality of customer and only customer. So let's enter in customer ID. This calculation will be calculated for customer ID, and then we want a count distinct of order ID. So that's pretty nice and simple. We're counting the number of orders for every customer ID. But what we're going to do now is click apply and OK. Now that we have this, let's use this in a fun data visualization that is actually relevant, that I have used in my organizations as well. So let's drag this into columns. Let's turn this into dimension. And as you can see, we have these numbers representing the number of times people have ordered. The next thing I want to do is take customer and drop it into rows. So now you can see for each customer we have one value, number of customer orders. All we want to do now, just to really finish this off, you can see it's already showing interesting information. I want to count the number of customer IDs within each bucket. let's turn that into a bar chart. And let's lastly change the columns into a discrete. So now we can see our nice little distribution curve of the number of times or number of customers with the number of orders. So we can see 5 is the most popular with 134 customers. The key is to actually do this pre-aggregation to calculate the number of orders for each customer is tremendously hard without LODs. It is possible, but with LODs we can create a very simple expression to give us this information. And as you can see, once we are done, we have our beautiful data visualization where we're visualizing the number of people who have made a certain number of orders. So again, have a think about how you can use this in your own organization with your own data sets. But I hope you enjoyed this quick demonstration of working with LODs to show customer order frequency. Level of detail expressions exercise, cohort analysis. In this exercise, we will write a fixed level of detail expression to help us create a cohort analysis. What we are going to do is that we are going to leverage the order date to see if we could find the first order out of the many per customer, so we could bucket them in terms of where they sit in our analysis, i.e. when did they join, how much have they spent over time. So let's give this a try. So with Tableau desktop open, first thing I want us to do is go to Microsoft Excel. Let's open our sample superstore data source. As always, let's drag orders into the query panel. Let's click sheet 1. We're ready to go. So let's start off by writing our level of detail expression. Create a calculated field. Let's call this customer first purchase. Now, if you're lucky enough that you have a beautiful data team that will give you this column, then you could just leverage it, great. If all you have to go by is the number of transactions and the values within those transactions, then an LOD is a possible solution. So for each customer ID, let's add the fixed. We want the minimum, again it's an aggregation, order date. Nice and easy. So now that we have this, let's bring this down. Let's drag this into columns. Let's drag customer ID into rows. And let's count distinct. Let's turn that into bar charts. So now this shows us when the customers had their first purchase. This is just one example, but we can take this one step further and do something a little more interesting. So what I want us to do is take the customer first purchase and drop it into color. I now want us to turn this into month. And now we can also see which month they belong to. So that's January's cohort, March. So we can have a lot of fun with this. What we can also do is take month, drop that into rows. Take customer ID and drop it into color. Now, instead of having bars, let's have squares. So as you can see, we're doing something very interesting here. We're now trying to see at which month do you get the most acquisitions. Obviously in this data source we only have 2016 to 2019, which is fine. If you have a newer version of Tableau, you can apply the newer data source. But there you have it. We are building something quite interesting. We can format this. add some borders. Let's add this to label. So we can actually now see the number of customers we had in each period. And there we have it. I hope you've enjoyed this. As you can see, we've taken the fixed level of detail expression to calculate the customer's first purchase based on the order date. Prior to this, we would have to bring in every single order. We would have to have done some amazing calculations, whereas now, look how clean it is. We've created a single expression, is bringing in a dimension that's not a part of the view, and we're leveraging it anyway. So, hope you found this interesting. Let's move on to the next lesson. Level of detail expressions exercise. Average sales per customer. In this exercise, we will write and include level of detail expression to help us create an average sale per customer. In this instance, we don't just want the average sale for all of our transactions. We want to see what is the average sale per customer or average customer spend. So that is a more interesting piece of analysis, and I would argue far more useful. Essentially, you're looking at the value per customer. So let's go into Tableau Desktop and let's get started. So as always, let's go to Microsoft Excel, open our data source, and let's take orders and drag that into the query panel. Perfect. Now what we are going to do is create our level of detail expression. We are going to call this sales per customer. We are going to make sure, the customer ID is included in our calculation, and we are going to have average sales. And the key thing here is I want to wrap this around with an average as well. So we're going to take the average sales, we're going to make sure that the calculation would include customer ID. That will give us a value, and then we are going to average that as well. Perfect. Now, let's us bring in a simple data visualization. Let us actually put region into rows, and let us double click sales and sales per customer. Let's turn this into average. You can see that typically the values will be similar, but they are different. And now we're looking at the average sale per transaction, which is the first column, and sales per customer, which is the second. So let's have a little bit more fun. Let's turn this into bar charts so we can actually see it now. Let's flip the axes, expand it again. And let's take measure values and drop it into the label. So now we can actually see the values against each other. And again, nice and simple piece of analysis. The key here is that actually we should also rename this, edit aliases, average sales for transactions. And let's rename this, edit aliases, average sale per customer. Again, the key thing here is that this is two different pieces of analysis. Without using the include, we would have had to bring in customer ID somewhere in the data visualization so that we can aggregate it together, and that would have just been a nightmare. If you wanted this analysis prior to LODs, you would have probably had to go to your data team and ask them to provide this for you, or go through multiple stages, whereas now this was quite simple to do. So have some fun with this, explore the concept, try to explore, include, and see you in the next lesson. Level of detail expressions. Exercise. Average daily sales. In this exercise, we will write and include level of detail expression to help us explore average daily sales for all of our transactions, but to visualize on a monthly basis. We do not want to see days, we just want to see months, but because we're calculating the average daily sale, we need to include this. So let's go into Tableau and let's get this built. So let's start by loading our data. Click on Microsoft Excel, Sample Superstore. Once this is up and running, take orders and drop this into the query panel. Let's go to our sheet and let's start by writing our include level of detail expression. Let's do this together. Right click, create calculated field. Let's call this daily sales. Average daily sales, nice and easy. Let's create an expression. Include. We're going to add order date and we are going to write average sales. So this will give us our average sales per day, and then we want to turn this into an average overall. Let's click apply. Now with this still open, we're going to build our data visualization to see this in action. So let's take order date, drop it at the top. Let's turn this into months. Let's put our region in rows. Let's double click on sales now. So this is our total sales for each of the months. And this is our average sales. Now what does that mean? It means that it's just taking all the number of sales and averaging them up together, which is a perfectly valid metric. It works. However, we want to average each of the days and then average them to get an average of an average. And that's what we've built with our include. Double click this. As you can see, the values are slightly different. Again, there are deviations. This is a different metric. But what we're doing now is we're taking the average for all the days of the month. It could be 100, 200. Therefore, what we don't have, or what we have, is we take into account each of the days. Each day has more weight. For example, if one day is a lot higher than another, this really is an interesting piece of insight. And again, we use average sales all the time. We aggregate on a monthly basis, but average daily sale is another KPI that, without level of detail expressions, would have been very, very hard to calculate, because we don't want to see daily data, but we want each individual day to be included in our aggregations. So have a little fun with this, explore this, apply this technique to your data, and we'll see you in the next lesson. Level of detail expressions. Exercise. Excluding from view. In this exercise, we will write an exclude level of detail expression to help us remove a dimension from a calculation. Now the key here is that you might have a visualization that is perfect, it's showing you what you want. But for example, in this case, we want to coordinate the colors in a better fashion, so therefore we want to remove a dimension. Let's go into Tableau so we could explore further. So with Tableau desktop open, let's load in our data. Let's click on Microsoft Excel. Let's select the sample superstore and let's bring it into Tableau. Let's bring orders and drop that into the query panel. And then let's go to sheet 1. From here, we're going to build a very simple data visualization first, and then we are going to demonstrate how we can use the exclude capability. So very simply, I want us to take category and drop it on columns. I want us to take order date, drop it onto rows. I want us to right click and select month. Let's actually fit entire view. Now I want us to take cells and double click. I want us to bring that in, but let's change this to a bar chart. Let's take cells and drop it into size. Here we go. Nice and simple bar chart. You know what? Let's remove the text. We don't need to see that. So the keys now we have the following. Looks pretty good, but I want to add some color. So let's take cells and drop it into color. Let's click on color. Let's choose something a bit more interesting. There you go. Now the key here is that we can see various patterns. However, you can see that within the months, within the categories, each of these bars are different colors. What happens though if we want to color based on March? So even though we've split our view by category, we want all of March to be the same color, all of April to be the same color. So we want to, in essence, remove category from our cells or from the field that we're going to use the color. So let's create this level of detail expression. Let's call this cells exclude category. So we're going to write a exclude category, and we want the sum of cells. Make sense? Now let's click apply, let's click OK, and now let's drag that on top of color. Let's change the color back to blue. And now you can see that all for January is the same color. You can see all of September is the exact same color. To make it a bit more apparent, we can change it from blue. Let's have some fun. Let's choose sunrise diverging. Because this way you can see that all the colors now match. The September's the same, October's the same. It's all based on the scale. Now, why is this important? Let's change it back to blue. It's because it gives you different insights. Instead of comparing individual months, you do want to see the breakdown by category, but you want it to be colored solely by month so you can see which month leads. Again, this is a very interesting example of how you can use exclude to remove a dimension, in our case category, from the current view. So therefore, the cells excluding category literally only calculates for month. Remember, we could have also done this with include, exclude and fix. We could always debate which one we should use. However, for me, this actually solves a very interesting problem using exclude by removing category. So have a play with this, explore this. Exclude is not used too often. For the most part, a lot of people use fixed. However, have a look at this. I hope you enjoyed this lesson and let's move on.